Okay, for this question, we simply have to match the graph with the equation and write the letter that goes with it. So the first one, y equals 1 minus 3x. It's a straight line graph, and we can see that the gradient is minus 3, so it's sloping downwards, which means it's either this one or this one. But if we look at the other part of the equation, the intercept, we know it goes through the y-axis at plus 1, which is positive, and only one of our graphs does that. It's graph E, which goes through there above the x-axis. So the answer to part 1 is E. Okay, the next one, y equals 1 over x. This is a reciprocal graph, and really you just have to learn what these graphs look like. There are two reciprocal graphs here, A and F, and which one it is depends on the sign of the number on the top here. And because it's positive, we know it looks like graph A. And if it were negative, it would look like graph F. So for example, the equation could be y equals minus 2 over x minus 8 over x. Doesn't matter what it is, minus something over x, and it would be graph F. Finally, this one here, it's a quadratic, and we can see that it has a positive coefficient of x squared, which means it's going to be one of the U-shaped ones. Okay, so it's going to be D or I. And to determine which it is, we can just look at the y-intercept here, the plus 3. That means it's going to go through the y-axis above the x-axis. It doesn't work for graph D, but for graph I, yes it does. It goes through the positive y-axis. So the answer is I. Okay, question 22. We simply have to complete the values for the table, so we have to substitute in the missing values for x, starting with x equals minus 1 into the equation. So I'll go through all the working here. For x equals minus 1, we would have minus 1 squared minus 3 lots of minus 1 plus 1, which is of course 1 plus 3 plus 1, which is 5. We put that in there. Next we substitute in x equals 2, so we're going to have 2 squared, take away 3 lots of 2 plus 1, which is 4 minus 6 plus 1, so that's minus 2 plus 1, which is minus 1, and that goes in the table. Finally, we substitute 3, so 3 squared, take away 3 lots of 3 plus 1, and that's going to be 9, take away 9 plus 1, which is of course just 1. And what we always want to do is check that there's symmetry in our table, because it's a quadratic and it should be symmetrical, and we can see the minus 1s, the 1s and the 5s spreading out from the middle. Yes, it's symmetrical, so that's a good sign, and we can carry on. So the next step is to plot it. So simply one at a time we're going to plot these pairs of coordinates. So starting with minus 2, 11, that's up here. Minus 1, 5 is about there. 0, 1 rather, is on the y-axis there. Then we have 1 minus 1, just down here near the bottom, and 2 minus 1, which is of the same height, and going back up to 3, 1, and finally 4, 5. And again, like we did with the table, we're going to check that this looks symmetrical, so we know we've plotted it correctly and it looks really nice and symmetrical, so we can go ahead and actually draw the line. This is quite hard for me to do on the computer, so this is my best effort. Hopefully you can come up with something that's a bit smoother than this. I don't think that's too bad anyway, but the key points are that it should be smooth. Okay, shouldn't be any kinks in it. That must suggest you've misplotted something, and it should be symmetrical, because all quadratics are. Okay, finally we're going to use the graph to estimate the values of x for which y equals 3. So we simply find y equals 3 on the y-axis, and we're going to draw ourselves a line which extends to meet our curve at various places. So it meets the curve over here, and it meets it on the left as well. Now if we go down from the point where it meets it, this gives me the x value, which corresponds to y equaling 3. And obviously there'll be some variation in the answers, because we're drawing this graph by hand, so you just measure it as accurately as you can, and give it to, from this sort of scale you can give it to 1 decimal place. So I'm going to go with minus 0.5 and plus 3.5 as my values. Okay, next question. We've got a graph already plotted, and it's the graph of y equals 2x squared minus 4x minus 3, and we're asked to find the values of x which correspond to 2x squared minus 4x minus 3 equaling 0. So if that equals 0, then for our graph y must equal 0, because y and 0 equal the same thing here. They both equal 2x squared minus 4x minus 3. So on the graph where y equals 0, that is the x-axis. So we just find where the curve crosses the x-axis, and it's as simple as that. We read off the values, and because this has been plotted by a computer, we can be quite accurate. On the positive side we have 2.6, on the negative side minus 0.6, and that's it.